Welcome everybody.
All right, get someone to pray for us, Uwe.
Now we will ask Bafana to pray.
Let's pray. Thank you, Father, for this beautiful day that you've given us. Thank you for everything that has happened. May you please guide us and protect us. Amen.
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 Uncle Khwezi, you may start.
Greetings to everyone in the group. Let me share the thing. I think I have a slide here that talks about who I am in terms of that. Okay, can you all see the slide?
Yes.
Okay. Okay, today's topic, we'll be talking about engineering in the aviation. I'm gonna say in the aviation world. And what I try to do is to limit the topic to an airport visit. So if you were to imagine yourself, let's say, going to Cape Town. What's happening? Okay. No, it was telling me to move something. So if you were to imagine yourself traveling from Johannesburg to Cape Town, you go through OR Tambo, and then you will land in Cape Town International Airport. So I want you guys to imagine taking that trip. The first thing that you do is you will obviously go through the doors, and then you'll probably get into some escalators, and then you're gonna get onto the bridge, you get into the aircraft, it flies, it lands on the other side, and you reverse the whole thing. So what I'll be doing today is I'll be taking you through the engineering that is around, what's the word? That is around you as you travel through an airport. But before we start, because it's the Sabbath, I wanted to start with probably a reason why aviation and engineering is beneficial to us. Jesus once said, "Go ye therefore and teach all nations, baptizing them in the name of the Father and of the Son and of the Holy Ghost." I'm starting with this verse because as Adventists and as Christians, we know we have a mandate to go out there to all the nations. And how do you get to all the nations? By foot. You know, it is very difficult to get to all the nations by foot. You will see as I present here that a trip that would normally take you an hour or two by plane will actually take you about 4 months walking or using goats and stuff like that. So God is pro, let me use that term, he's pro aviation because it is also a means by which we can go out there and teach all nations. I'm gonna probably try and I don't know, I'll try and be fast. I know I speak too much, so you'll forgive me for that. This is our scope. So I'm gonna first talk about, I'm gonna give you a background, my background, and then I'll tell you the presentation, what it will entail, and then I'll just give you a brief definition of what I mean by aviation and what is meant by engineering. And then from there, we'll look at the airport terminal, and then we'll look at mechanical, industrial, electrical, and civil engineering that you see when you go to an airport terminal. Then we will look at now the other buildings, the outer buildings on an airport or the whole aerodrome, which is your control towers, your runways, your fuel installations, your fire and rescue services, and hangars. And then we're going to look at aircraft, the aircraft itself. When you enter the aircraft, I see those lines. So when you enter the aircraft, then there's engineering that's happening there, and then we'll quickly look into that, and then we will conclude. There'll be time for questions and answers and other interesting discussions. That is, if I finish in time. So let me do this. Okay, so my name is Khwezi Toni, as you've all heard. I work for the Defense Force, specifically the Air Force. I've been married since 2016 now. I have one child, a girl, and I have another girl on the way. She's due on the 17th of August. So I'll be a father of two soon. I joined the SAF, or the South African Air Force, in 2005. And I've been working there ever since. So that's where the over 15 years of experience comes in. In terms of education, I didn't start right at the top. Unfortunately, I started at a college. So I went through almost all the different kinds of engineering, whatever you want to call it. I started at a college, and then I went to a technical, and then I went to a university. And I'm not a pilot. That's the other part I wanted to. That's why I wrote it there. I'm not a pilot. I know people think if you work for the Air Force, you're a pilot. I'm not a pilot. I'm definitely not a pilot. And I'm not interested in being a pilot, but that's just a personal thing. I like my feet firm on the ground. I don't like being in the air that much. So I'm going to focus on, as I said, on an airport or an aerodrome environment, but more specific on commercial aviation. I'm not going to talk about military aviation or the Defense Force and stuff like that. And then I'm also not going to cover space related engineering. I remember the other day you guys had someone was talking about the space station and stuff. I'm not gonna talk too much about that, even though that's part of aviation, but I'm not gonna talk about that. Remember, I started with go ye therefore and teach all nations. I don't know if there's anyone to evangelize in space. But anyway, so our focus will be on what you see on this picture here. If you can see my mouse, can you see my mouse? If you can, please just say sure. The mouse, the pointer. Can you see a pointer on the screen?
Yes, you can see a pointer.
Okay, you could. No? Okay, let me do this.
Yes.
So this is your airport. Yeah? Then this is inside the airport. This is an aircraft. This is, I guess, someone who's enjoying their stay or their flight. So that's what we'll be looking at. This is your ticket and all these other things. So with all this stuff, there's engineering happening here. It would probably not be possible if it wasn't for engineering. And then this is a typical plan of an airport. This makes it a bit difficult, these lines. But anyway, okay, yeah, I can still read them. So here, this is a runway. This is what we talk about when we talk about the runway. This is where your aircraft lands and takes off. And then these ones here, these are taxiways. So sometimes you'll hear where someone will say an aircraft is taxiing off, and that means it's driving here to the runway, or it's driving from the runway back to the apron. In apron, it's where aircrafts, that's where people get on. Yeah, let me use that term. And then, but this is your terminal. So you usually you get in through a terminal, and then you will walk somewhere through, and then you go. The aircraft will be parked somewhere there. You go in there, you get into the aircraft. It goes through this, and then it goes on the runway. The other stuff that are important on this picture is the tower. This is where the air traffic control happens. So this is how your planes know where to go. All of that is controlled in the tower. And then you have a fuel depot. This is where you have fuel that is refueled onto the aircraft themselves. And then other airports will have a helipad. That is where helicopters land. And then this is also important. This is your fire station. If you look at the fire station, you'll see that it has access to the runway. So that in case something happens when an aircraft lands or takes off, these guys must be the first people to attend to those people there. I'm not going to talk about the other stuff like parking and things like that, but they form part of the airport as well. Okay, this is the same thing. So this is your tower. Those who don't know what a control tower it looks like, this is an ATC tower. It's an aircraft traffic control tower. And then this is your aircraft. This is the terminal. This part we call it the terminal, where people walk around like the mall and stuff. And then this is your runway. It's not a runaway, it's a runway. I've heard a lot of people say runaway. So in aviation, yeah, I've listed two basic definitions of aviation. The first is that it is the art of science. It is the or science of flying an aircraft. It is the design, the production. It deals with the design, the production, and the maintenance of an aircraft. So when we speak of aviation, we're talking about the art or science of flying an aircraft. And then the second definition, it's the activities surrounding flight and the aircraft industry. So I decided that I'm going to focus more on the second definition, which is the activities surrounding the mechanical flight and the aircraft industry. So I want you to imagine a world without engineering. This is probably what air travel would look like if there were no aeroplanes. If you see, can you see what is happening here? This is a guy who's trying to, I guess, is probably the pilot. This is the pilot, and these are the passengers, and that's where the cargo is. So to avoid things like this, engineers decide to design aircraft. What's happening? Okay. So before I continue, though, I also want to give you a definition on engineering. What will I be meaning when I speak about engineering? So the definition of engineering, another basic one, it is the scientific field that involves taking our scientific understanding of the natural world and using it to invent, design, and build things to solve problems and achieve practical goals. So if you have questions, please write them down. I'm going to try and go through the presentation as fast as possible. So please write them down and ask later. This for me is very important because we have a lot of people who are called engineers, but not all engineers are engineers. I don't know if that makes sense. And the reason why we need to also, especially with parents as well, to understand this is that we have a lot of parents that would discourage their kids from studying anything engineering related because they have a misunderstanding or misconception of what engineering is. Example, the guy that fixes the car, I usually make this example, the guy that fixes the car, you know, if there's a neighbor of yours who goes under an engine and fixes the car, and that's what he does every day, that guy is not an engineer. Even though people might call him an engineer, but he is not an engineer. He is a mechanic or he is an artisan. You can maybe even say he's a technician, but he's not an engineer. So another example, the person that fixes your clothes. You know, when your clothes dies at home, your father will probably change it. But the person who does your electricity at home, that person is not an electrical engineer. He's an electrician. He's also an artisan. And the person who builds your house, you know, the one who puts bricks there, that person is not a civil engineer. He's a builder. He's also on the artisan line. So if you look at our definition, the engineering, it is about solving problems, but it is about designing. There's design, it's part of it includes inventing, it includes designing. And designing, per se, you are more interested in, if I were to use again the example of, let me use an example of a table that I'm using right now. So an engineer is interested in, will this table fall if I put, let's say, 20 kgs on it? So he will say, okay, so that the table doesn't fall, let's use this type of wood, let's use this type of materials, let's make it this thick or this thin or this big, and things like that. There's also part of engineering is called economics. Economics deals with heights, you know, it mustn't be too tall, it mustn't be too short. At the end of the day, as an engineer, what you are trying to do is you are trying to solve problems. So in a car, you might not even know how to fix a car when you're an engineer. But what you might know is, how do I make the car faster? What must I do on the engine to make the car faster? Once you do that, once you design the right material for the engine, the right material for the body and the frame and things like that, you then, you know, give it to a draftsman who's gonna draw everything, and then that draftsman will give it to the technicians and the artisans who will make what you are drawing, what you have designed. And at the end of the day, you might sometimes you might not even recognize something that you yourself have designed. So when you speak of engineers, you are talking about people behind the scenes. So for you guys to understand, I made a few examples here too. I'm just going to talk about these two examples. The first is the Noah's Ark. So the design of the Noah's Ark was God. If you read there, you realize that Noah received instructions on what to build the ark with. He received instructions on how big the ark must be, the compartments, everything. So the designer of the ark was God. But the person who made the ark was Noah. So in this case, I would say Noah was not the engineer. Noah was the artisan, or Noah was the technician. God was the engineer. Again, another example would be the Ark of the Covenant. Same with the Ark of the Covenant. God was the designer. He told them how, what measurements, how they must make it. He even went as far as to even tell them who will help in the construction of the ark. If you read the following verses that I wrote here, you will see that he even told them that Bezalel and whoever that guy is, they will do this. So God chose the design, he chose the materials, and lastly, he even chose the people themselves. Engineering is found in the Bible. If you will read these verses, you will also see that it is encouraged in the Bible. But I also wanted to say that with the last verses, when you read about the Tower of Babel, you see that sometimes engineers can go haywire and they will design wrong things, and God will intervene. In this case, it was the Tower of Babylon. And they designed a tower that's supposed to go to the heavens, and God wasn't pleased. Okay, let's try and move quickly. This was just to show you guys the difference between walking and flying. So on the red line, whoever drew that red line, that is where Babylon is. Back in the days when we were speaking about Babylon, if you remember, Daniel went to Babylon with the Israelites when they were captured. So they walked from Jerusalem all the way to Babylon. That is a 235-hour journey. I didn't convert it to days, but It's 1,156 kilometers. If you were to walk using, or maybe ride a horse or something like that, as a family and as a group of people, it will take you probably 4 to 6 months. I don't know how long it took them, but by flight, it's 2 hours. So this is why aviation is important to us. This was Paul. Paul, when he was evangelizing in Asia, he walked and used horses and used boats in all these trips. But if he was flying, let's say if he had a helicopter and he was flying, he would have probably reached most of his destinations within a matter of hours rather than months. This is the Israelites when they walked from Egypt all the way to Canaan. They took 40 years. We all know that they took 40 years, right? But by flight, they would have probably taken an hour. Okay, then moving on to probably the interesting part for most of you guys. This is the types of engineering that you see when you enter a terminal. So you have mechanical components, there's industrial engineering there. I heard that you guys will be talking about industrial engineering in the north, so I think this month. So I guess this ties in with that. Then there's electronics or electrical, and then there's civil. Let me see if I have, okay. So this is a schematic or a layout of a terminal. This is what a terminal looks like. If you look here, these are chairs. This is the departures lounge. So when you enter an airport, you will usually see a lot of chairs. This is those chairs. These are those chairs. And then you will see number 2, there's gates and jet bridges. If you see my case again, these things, these things, this is called a bridge. So when you leave the gate and you enter an aircraft, you go through something that is called a bridge. This is what that is. So this is also designed, okay, that's mechanical anyway. And then you have security gates. These are the security gates. If you look at where the security gate sits, usually your industrial engineers working with architects will choose the best place for these things to be, so that you avoid keeping people in long queues unnecessary. Then you have your baggage claims. These things are called carousels. This is where you usually get your baggage from. And then what else did I forget? Oh, these are your check-in tables. This is where those ladies usually sit, and guys these days, and they will check your tickets. So mechanical components on an airport. So, okay, maybe let me say this. One of the reasons why I'm doing it like this is so that I know you have different people that are interested in engineering, but they're interested in different things in engineering, but they would still love to work at an airport or in the aviation industry. So this is so that if you love mechanical stuff, you love, let me say, cars, engines, and all those things, this is probably, if you don't work with the aircraft itself, but you still want to work at an airport, this is what you'll probably be dealing with. You'll be dealing with lifts, you design lifts, you fix them, and all those other things. You deal with escalators, designing, fixing them. Carousels, these are the baggage, that stuff where you take your bags from, and then the structure itself. These are part of your mechanical systems. I forgot one thing, HVAC. So the air conditioning system that is at an airport, mechanical engineers usually deal with that. Even the fueling systems. And then industrial engineers. Industrial engineers at an airport, I would say their biggest contribution, probably, I hope I'm not wrong, I hope they won't kill me, but their biggest contribution is that they try to make sure that we get in an airport as quickly as possible and get out as quickly as possible. So when you see long queues in Pick and Pay and stuff like that, you must know that they probably didn't use industrial engineers because they shorten processes. Their job is to make sure that processes are quicker. So, as I said, the position of the gates in an airport. the check-in counters, your parking, you know, how parkings work. I don't know if you guys have ever seen these days when you enter a parking lot, you will see, it will tell you if the parking is full or not. That's also part of where they fit in. But in this setup, their main job is to make sure that we don't wait as unnecessary. Then you have your electrical and your electronics. Your electronics guys, the main difference between electrical and electronics is it's usually the current or the power that they work with. So electrical guys, your house, your buildings, stadiums, airports, things like that, the heavy power that's needed. And then electronic guys will deal with light current. They call it light current, but that is now your computers, the electricity inside your computers. If you were to give something over 220 volts on your computer, it will probably, you know, burn. So that is electrical. So the electrical electronic guys, they help us with these screens. This is so that you don't get lost. You look at this, it will tell you this is the aircraft that you are taking. This is the number of the aircraft number. I think this is where you are going to. So if you are going to, in this case, Amsterdam, you know that you're supposed to be on this aircraft, KLM, whatever, and then you must board it at gate 820. Unfortunately, the gate is closed. It means it has left you behind, so you must just board it. But anyway, that's what they help us with. They also help us with the power, the backup, in case there's no electricity. You don't want this screen to go off, otherwise people will not get into their flights. And many more communications. I don't know if you've ever had someone who's being called in an airport. They will call you, they say, hey, so and so is lost. They help us with those things. So that's part of communication. And then you have civil guys, the civil engineering guys. They design the roads. Can Carol write, if it's a question, can Carol write the question down and then we'll ask later on? So they deal with roads, they deal with the building, the structure itself. I would say mostly it's movable assets. So if you see something, let's say you're walking and you see a big hole, the person who's probably going to fix that or who designed that, those are your civil engineers. And then, okay. So the reason why I raise these things is to show that you can still work in the aviation industry. You can still work in that airport setup in aviation without necessarily working with aircraft. So if you like building things, you will still be able to work in this setup, even if you are not necessarily mechanical. That's what I wanted to show. The other thing is that if you like working with your hands, maybe I should have said this when I was speaking about engineering. If you like working with your hands, so in other words, you like to be the guy under the car holding a spanner, maybe starting a degree in engineering might not necessarily be for you. Most engineers spend their time behind a desk in an office. Most of them don't even know how to change tires. I hope they won't kill me, but some of them don't even know how to change tires. But they can design a tire for you, tell you what material must the tire be and all those things. But if you say to him, change the tire, they might not know. So that's what I'm trying to say, that if you like working with your hands, then maybe a college is good for you. And to a certain extent, a diploma is good for you. But if you like designing, understanding how things work, solving problems, not necessarily implementing other people's solutions, but creating solutions yourself, then engineering is for you. Okay, then we move on to control towers. So what I did with the outside part is I tried to change it rather than to just say mechanical or electrical. I decided that I'm going to look at a certain part that you guys might have noticed in an airport. Then I'm going to tell you what engineering goes into. This is a control tower or an ETC. These people that are sitting here, these ones that I'm pointing at, these are called air traffic controllers. They control the planes. They make sure that planes don't crash into each other. They make sure that planes don't go into the runway at the same time. They make sure that planes don't start moving at the same time. They make sure that if an aircraft is coming in and another one is coming in, they will tell this other one to wait and do whatever. These guys, if without them, there would be a lot of aircraft accidents. Let's put it like that. And it would be chaos in that airport. So they do the coordination there. But in order for them to do that, they need to communicate with the pilot, they need to communicate with the terminals, they need to communicate with the ground crew. I don't know if you've noticed, when an aircraft lands, there are those trucks, the buses that come, trucks that come with the stairs and everything. So these guys will communicate. They will tell them that, okay, now the aircraft has landed, then those guys will start moving. So without that communication, this process, this thing that we see would probably not happen. And those are your electronic guys who help with that communication. They are or your software engineers as well. There's a lot of software engineering that happens here. These guys also help sometimes with the landings. If sometimes pilots require sight, they need to see the runway in order for them to land. But if it's too windy and there's a hailstorm and all these other things are happening and they can't see, they rely again on the guidance of air traffic controllers in terms of where to land. And then you also have people called systems engineers. I work as a system engineer in the Air Force, even though I studied mechanical in university. I work as a system engineer. So basically, a system engineer, it's a combination of engineering disciplines. Your job is to make sure that all these things fit in together. So if you design an aircraft, for example, you'll find, I'll show you a slide. The engine might come from US, the wings might come from China, and maybe the fuselage or the body might come from Australia. Your job as a system engineer is to make sure that even though these things were designed in different places, they still work together. So my specialty is on aircraft systems and it's passenger systems. Let me quickly move. So these are the runways. So here, the engineering here that happens here, it's mostly civil. What you see here, it's mostly civil. So civil engineers, they maintain these runways, they design them, they build them, probably with architects and town planners, I'm not sure. But the people that actually do the designing, it's civil engineers. So they need to make sure that, when an aircraft comes in, it's a heavy object that comes in at a very fast speed. So if you were to imagine this one as a runway, and then this is an aircraft. When it lands, this is what it does. It will always land at a high impact. The runway needs to be strong enough to handle those weights. And that is why you need engineers to design these things. Also to maintain them, you also need engineers because you don't want this to be compromised. There's actually an organization called International Civil Aviation Authority that has regulations on how these runways must be maintained and who must maintain them. And they will tell you that it's an engineer and a group of technicians. Civil engineers are also responsible for the taxiways as well. So this is a taxiway. So an aircraft does not land or take off here. It only lands or takes off there on the runway, but it will travel on the taxiway when it goes back to the terminals. Then they are also responsible for building the other structures. I'm not gonna be much. And then this is, okay, I didn't put a picture of the fire station. You can see that this is our fire station, but these are firefighters. Here I wanted to show you that firefighters are necessary because of accidents. This person probably missed the runway and ended up here. And the fire might start, and so the firefighters are there. But there's engineering here as well. So there's civil engineering to design the fire station itself. You have mechanical engineers who design these things, and then you have fire engineers as well. Those who don't know, there are people who are called fire engineers. Basically, fire engineering is also important in the aviation industry because they also make sure that the materials that are used in an aircraft are not easily flammable. Then you have a fuel depot. Back in 2007, 8, 2008 up until 2010, I worked in a fuel installation in one of the Air Force bases. And basically what you do is to make sure that there's always clean, efficient fuel for the aircrafts. And these things can carry hundreds of thousands of liters. I think probably this can even be close to 500,000 liters of fuel on one of these tanks, on any of the tanks. So here, there's also civil engineering happening because of the pipes, the structures, the tanks themselves. There's mechanical as well, and then there's petroleum. So when you study petroleum engineering, it does not necessarily mean you'll be working at a petroleum site in ABP in Mossel Bay or something like that. You might find yourself working at an airport as well, handling this whole system. Back in the days, there were things called bowsers. Bowsers are trucks that carry fuel on their bed. But today, the design has changed such that the fuel leaves from the tank, it goes through these filters and these hydrants, and then it travels underneath, and then it will, see if you see these holes, it comes up from these holes. Then you have your bowser operators, the fuel attendants. They then will couple a hose from here to the aircraft and pump the fuel into the aircraft. So that's engineering. In that engineering is petroleum. So regardless of what
mechanical engineering is 4 years, including.
So regardless of what engineering you study, if you love the aviation space, you are, I would say, guaranteed not guaranteed, okay, I don't employ people, but you'll find a field that fits you. Let me use that term, that fits you there. Be it civil, be it mechanical, be it petroleum, be it industrial, be it electronic, be it software, and there's many types of engineering fields out there. And then probably now let me move to the exciting bit that some of you guys might like, the aircraft now systems. These are the different types of aircrafts. There's actually 3, but I made it 4 to make it easy for us. So helicopters are called, they are rotary wings aircraft. What that means is that the wings themselves are rotating. So that is what you mean by a rotorcraft or a rotary wing. The wings rotate. So I need you to know these differences. The wings are the ones that do the rotation. Then the second type of aircraft are fixed wings aircraft. They are called fixed wings aircraft. These are the ones that this is the one that when you go to an airport, you are more likely to use a fixed wing. So these are the wings of the aircraft, and the wings do not move. They are fixed they're in a fixed position. What I did is I decided I'm just, for this presentation, split them into 2. So you have the big ones, and then you have the small ones. These are usually, your acrobatics, the guys, I don't know if you've been to an air show, those guys that do those things with the aircraft loops and all those other things. They usually use these ones. And then these ones are like your cargo ones, where you carry your furniture and your parcels and everything, and your passenger ones, where you carry your people. So at work, I work with, I used to work with these ones, but now I work with these ones, the bigger ones. And then the other type of aircraft, it is your hot air balloons. So some people didn't know that hot air balloons are aircraft. But hot air balloons and zeppelins, these are called lighter than air aircraft. So the philosophy they use is they need to be lighter than air. So you blow a balloon, it becomes lighter than air, and then it starts going up. That's the philosophy behind them. And then there were things back in the days that were called zeppelins. They used to burn a lot. I think I don't have a picture. For some reason, I didn't put a picture of a zeppelin. These dates just show you when was what invented, or when did these things come into life. So you can see that helicopters, they came about around 1923. Fixed wings around these are commercially around 1914, the big ones. And then the small ones, 1905, Wright brothers. And then these ones are the oldest ones. Okay, then I'm going to move into, what I did is I grouped the aircraft engineering part into 3 categories. So you have your mechanical, your aeronautical, your structural, and your metallurgical guys. I grouped them as one. Even though they don't do the same thing, but I grouped them as one. So on an aircraft, you have different systems. You have an airframe. An airframe, this is an airframe. The body with the wings and everything, that is an airframe. And then you have, when you speak propulsion, we are talking about now the engines of an aircraft. And then when we speak propellers, we're talking about, those wings, those blades that rotate like this. Those things are called propellers. So the mechanical guys and the structural guys and the metallurgy guys, they deal with that aspect of engineering. So if you study mechanical engineering or aeronautical engineering or structural engineering or metallurgical engineering, and you want to work in the aviation industry, this is where you are likely to work if you want to work with aircraft. This is the part where you are likely to work. And then you have something called a cockpit on an aircraft. A cockpit, that is where, if you've seen where the pilots sit, there's a lot of screens and buttons and instruments and all those things. That thing is called a cockpit. So the engineers that work in that environment are your avionics guys. We call them avionics, but they are your electronics engineers. So the word avionics is actually a combination of aviation and electronics. So he's an aviation electronical engineer. Avionics. So they design those avionics. Most people who are called avions, who are now your maintenance engineers, they don't design the avionics, they fix them. So someone else designs these things, someone else fixes them. Same thing with the mechanical. One person designs the engine, the other person will fix the engine. Your aircraft maintenance engineers, I think there was a lady who presented as an aircraft maintenance engineer. She fixes, she does the actual fixing of the engine, but she doesn't design the engine. Your propulsion engineer will design the engine. And then the last part that I wanted to talk about was industrial engineering. So if you study industrial engineering or systems engineering, you are more likely, when it comes to an aircraft, your job is more on the bringing everything in together again. Remember, now you have your mechanical engineers, you have electronic engineers, you have structural engineers. All these people are doing all these different engineering things. But someone needs to make sure that when these things come together, they will still produce an aircraft that can fly. And those people are called system engineers or industrial engineers. It just depends on where you are. They also help with the layout of the aircraft. So if you go into a passenger aircraft, you will see that some will have 2 seats on the left, 2 seats on the right. Some will have 4 on the left, 4 in the middle, 4 on the right. Some will have stations in between. Other aircraft will have, like your Boeing 747, they will have an upper level, and then there's a middle level, and all these other things. So industrial engineers also deal with making sure that the way people see it, the spaces and everything, you know, everything works again together. If there's an emergency, we have enough doors to ensure that people can leave as quickly as possible and people can also get in the aircraft as quickly as possible. And then they also help with the manufacturing. So there's something called final line assembly. You are more likely to see industrial engineers there than systems engineers. So where the aircrafts are being made, there's a place where they are getting assembled. So they will tell you what must go where first, what must be fitted to what. Let me quickly move on. Okay, so these things, these blades here, if you guys can see the blades, these blades are called propellers. You see these things here, they are called propellers. So you have engineers, mechanical, structural, or metallurgy guys that work on manufacturing and designing these things. These things are called propellers. And then behind the propeller, there's an engine. This thing is covering an engine. And underneath these things, that's where you have your engines. So your mechanical guys design the engines. And then this shell, now the shell and the wings and everything, this is your airframe. And again, you'll have your mechanical, your structural guys. Some of these airframes, back in the days, they were made of cloth, sometimes they were made of wood. Today, most are made of aluminum, but there's composites now coming in. This is now where the electronic engineers come in. Even your software engineers, they come in.
Sorry, request. Are those your arrows or somebody drew the arrows?
No, they're not mine.
Ish. You know
They're
what?
not,
You
they're
have
not my arrows. I don't know. I can't even remove them.
so you need to restart your presentation. Just stop sharing and then load it again. But you also
What's the time?
so this is what you need to do.
Let me. Okay, I didn't get that part. What must I do?
So start screen sharing.
Okay.
And then there's a bar located at the top where it says
I did it! I meant it!
It says a note.
more.
More, yes.
Click on more so that you get the drop down menu.
Yeah.
And then there's a place where it says disable attendee annotation.
Or disable participants. Ne?
Yeah.
Okay.
All right.
Is it fine now?
Yeah, I think now no one can draw it.
Okay, I'm gonna continue. I'm gonna try and move quickly. I see time is against me.
All right, sure.
Okay, so here, guys, now what you see is this is your cockpit. They call this place a cockpit. This is where your pilots sit. In between the pilots, there's usually another chair that comes up. That is where usually your flight engineer sits. The flight engineering guy is someone who's good at fixing things on the go. He's called a flight engineer by tradition again. It's not from four-year engineering degree part, but it's a flight engineer.
I have a
You
question.
didn't know which button.
Okay. And then, sorry. So this is where now the industrial engineering and systems guys fit. Remember what I was saying, that sometimes you will have different parts coming in together from different places. So most aircrafts are not made in one place. The engines, you know, these are engines that probably, maybe let's say in this case, were made by, I don't know, I'll just assume, let's say they were made by Rolls-Royce in the US. And then the fuselage, if you look at this big thing, it's called the fuselage. The pink parts, they were made in Hamburg, that is in Germany. The blue parts were made in France, I think. The green parts were made in Spain. The yellow parts, I don't know, probably Spain as well. But other parts here, you can see other things were made in China. So systems engineers need to make sure that when all these things come together, I mean, here we're not even talking about the electronics and the wiring inside. We're not talking about the chairs. We haven't even touched the cockpit. But when all those things come together, they need to make sure, you see these green parts were actually made in England or in the United Kingdom. But they need to make sure that everything will fit in, everything will work, and the system will perform as desired. So that is a special kind of engineering that you also study. Your job is to make sure that the different engineers can work together. It's crucial, it's one of the important engineerings today, systems engineering, because if you look at your phone, for example, you see there's electronics, there's communications, there's all these other things. So they make sure that those things still work together. When you talk about space flying, the systems engineering working there, because you have different kinds of engineering again coming together. Then that almost finishes my presentation. So here I wanted to also look at other technical fields. This is not all of them, but these are the other technical fields that when you go to an airport or when you think aviation, that you can also think of. You have architects. These are the guys that, you know, the look of that airport, the way it's shaped and all those funny things there, the nice structures that you see. Architects usually are the ones that will design those things. With and in terms of the material, how to get it to work now. You know, sometimes architects will look at it mustn't be visible, so they will want maybe a very small rod or supporting structure. So the structural guy needs to find the right material to suit those needs. It's not to say that he's not going to do the mathematical part of it, the architect, but architects are also part of the technical guy. So if you like drawings, you like designing spaces and all those other things, you can still work in the aviation world as an architect, designing the airports. And then you have people who are called airworthiness engineers. These guys are very important because for an aircraft to fly, it needs to be airworthy. They call it airworthy. Airworthy, you know, it means that the aircraft is safe. It means that it will not break apart whilst it's in the air. And it also means that it can land in almost any other country in the world because you have organizations that monitor the airworthiness of aircraft. So an example, if one aircraft from South Africa flies to China and there's, I'm not going to quote it, but there are things called airworthiness directives that are usually issued by aviation authorities. If they say that this type of aircraft needs to be checked ABCD, and an aircraft goes to China and they did not check that thing. So China can say, no, this aircraft is not airworthy, so it's not going to fly, and therefore it will not leave China. Otherwise, it might fall on top of people in China. So you have people that look into those things and they make sure that aircraft remain airworthy. As aircrafts age, they become less airworthy. They require more maintenance, more servicing, and people like to cut corners. So in the past few days, you will see that a lot of Boeing 747s, the nice ones have been, you know, Qantas, I think they decided they're selling theirs. A lot of companies are, Qantas, I'm not sure the other one now. I heard it on the top of my mind. But that's because there's a lot of maintenance and work involved, and it's not easy to keep them airworthy. So airworthy engineers deal with that. Then you have fitters and technicians. These are the guys that fix your aircraft. These are your AMEs, your aircraft maintenance engineers. You had a presentation. I'm not going to deal on that. Then you have air traffic controllers. Air traffic control requires a lot of maths and science as well. It does require, it's a stressful environment, but it's also one of the technical environments that people who like airports should consider. So when you think of a traffic cop on the road, even though they don't like this, but I would say if you think of a traffic cop on the road, someone who controls traffic, you know, like when you go and the robot is not working and there's a police guy say, do this, and those, they do a similar thing, but not on the ground. I forgot now, there are also people like that. Then you have aircraft investigations, investigators. A lot of people like this field, but this is now when there's an accident. You need to figure out what caused the accident. And that requires a lot of engineering as well. With your technical and your engineering skills, you can also get there as well. And then you have airport managers. These are the guys that deal with the everyday running of the airport. Places you can work outside of airports with these aviation related things. If you still want to work in the aviation space, it's the military, Air Force. I work in the Air Force. Then you have places like CSIR, you have places like Armsco, you have places like DNL. So they have military sections that do research and development for military, and they manufacture military stuff. Then you have your space agencies. You have your SANSA, South African National Space Agency. You have your NASA, which is the US, and then I forgot what the Russian ones and the Chinese ones are called. So here, yeah, and then you have your automotive industries. In the automotive industries, you can work for the OEMs. So you can still study aeronautical engineering. You can still focus on aviation, but you still find yourself working with cars. By automotive, I mean vehicles and cars. And by OEMs, it's original equipment manufacturers. So you could be a qualified person who's an aeronautical engineer who has specialized with a PhD in airflow, how air flows over an aeroplane, and you find yourself working for Ford or Mercedes-Benz because they also want their cars to be as fast as possible. So you can also work for racing companies or aftermarket modification companies that make cars. I don't know if you've seen people who paint their cars. So with your engineering, you can also find yourself in that environment. Then you have aircraft OEMs. You can work for airframe OEMs like your Boeing, your Airbus, all these companies that make Bell, that make aircrafts and helicopters. Then there are companies that make engines. Those are your CFMs, Rolls-Royce, Pratt & Whitney. You can also work for those companies with these skills, especially if you have an interest in the aviation industry. So you can move from there to your airports, or you make those rotating wings things. Then you have airliners, SAA, Qatar, KLM, Emirates. You know, SAA has SAA technical, so they fix their own. We're not going to discuss SAA, but they fix their own aircrafts. So as an engineer, you can still work for SAA, not to fly the aircraft, but fix the aircraft and to make sure that their aircrafts remain airworthy. Then you have aviation authorities. I left your Y. Aviation authorities. These are your SACAA. This is South African Civil Aviation Authority. So these are the guys that will go there and they will look at your aircraft and they will tell you, no, it's not airworthy, it's not going up. These are the guys that will issue regulations on where to fly, how low you must fly, and all these other things. They come up with all those regulations for that. There's FAA if you are in the US, and then there's EASA if you are in Europe. I heard there was someone from the UK, but those guys deal with EASA. And then there's International Civil Aviation Authority. That is a UN organization that is, I guess, it's like the mother of all these other companies, all these women of all these other civil aviation authorities. I gave this slide in here that in the future, some other time, we can also look at how aircrafts fly. So we'll be specific now on the aircraft itself. How does it fly? How does it go up? How does it go down? Flight mechanics and stuff. And then the other one is we can look at propulsion systems, you know, how does it go forward and back? How do rockets work? And the aircraft engines and the gearboxes, the types, that deals with that. And then the other one that is most interesting for me, it is God and engineering. You know, sometimes people don't think there's engineering in religion, but there actually is. And I think when we started today, we tried to show that even God himself was an engineer. The first project that God made, that he designed and he made. So he was all type of engineers. He was the designer, he was the manufacturer, he was the artisan, he was everything, was when he made the heavens and the earth. But we can one day look at God and engineering. And then, yeah, now it's time for questions and answers.
Yes, I've got a question.
Okay.
My question is, so if you are a co-pilot, what do you do?
A co-pilot.
The presentation
Yes.
so that you can see that.
Yeah?
I'm saying you can
Sorry,
stop.
A co-pilot. When you're a co-pilot, what do you do?
Okay, let me answer it like this. Ne? Remember, I said I'm not a pilot. Ne? So it might be difficult for me to even tell you what a pilot does. I'm joking, but this is what I'm gonna say. If you've watched movies, I think they will give you the best answer. In case where something happens to the pilot, to the main pilot, usually a co-pilot will take over, take charge, land the aircraft and all those other things. But some aircrafts are big and some of the maneuvers require two people. Most of them can be done by one person, but some require a second person. So a co-pilot in many cases is more of a redundancy or contingency in case something happens to the main pilot. Then the co-pilot takes over the aircraft and he will fly it to safety and he will land. The second part is rotation. Sometimes some of these flights will, you know, you can't be driving for 20 hours or for 24 hours or for 15 hours or something like that. So one guy will fly and then the co-pilot will take over. But co-pilots are usually less experienced than your main pilots. But that's basically it. I mean, let me do this. Sorry, let me do this. If you look at this stuff, yeah, if you look at this, it's almost the case of whatever you see on the left, you see on the right, yeah? Except for a few instruments. And if I remember correctly now, your pilot always sits on the left, forgot what they call it, port side or something like that, and then your co-pilot sits on the right. So if this guy faints, this one will not have enough time to stand up and sit this side. So basically the aircraft these things almost replicate themselves except for a few of them. So that is what a co-pilot does. He helps this guy to fly the aircraft, and when this guy for some reason gets a heart attack or stroke or something, or he's tired, then this guy takes over.
Okay, thank you, Khwezi. You can stop sharing.
Okay.
So that
Thank you.
Tolo, you can ask your question now. Tolo, you can ask your question now.
How do aeroplanes stand?
Tolo, you know, I don't have that picture. I watched the previous presentation, Shepard, when I forgot his name now. Pilot Mteto, I think it's Mteto, never the name. Yes, I remember specifically one of the answers for one of the questions he was asked was how do aircrafts turn? And he answered that question. If I had let me see.
Maybe we can help Tolo by referring him to the YouTube channel. I'm sure he hasn't been there before. So Tolo, I'm going to post the YouTube channel for you here, and then you can get the question answered. There.
If let me see. I'm looking at my presentation. If I can see, okay, maybe this can work. Yeah, maybe. Sorry. So this is what I'm gonna do. Let me do this. If you look at this, Tolone, quickly, it depends on when you mean 10, it also depends on what you mean. You mean up or down, left or right, or things like that. But there are different instruments, let me call the instruments on an aircraft that are used for aircraft to turn. So you have things like your radars here. This is this thing. So what happens is when you want to turn an aircraft, let's say to the right, in this case, this part here, let's say your aircraft is only going to the right. You don't want it to do this. You don't want it to do this. You just want it to turn like this to the right. Part of that propulsion system thing, you will see that you need to keep your powers and everything the same. But what happens is that this part here, this thing at the back, the rudder, is shaped like this. And what you need to do is you need to flap it such that it leans towards the right. As it leans towards the right, what happens is the aircraft is moving forward in a forward direction. This thing leans towards the right. There's air now that starts hitting the rudder on this side. So if the air hits the rudder here, what happens to the aircraft? It starts doing this thing. I don't know if that makes sense. It's the same thing as when you look at your airlines and everything else. If you want your aircraft to do this movement, you play with the flaps and the airlines and all these other things. And you play with them using, they call it Newton's third law. You guys know, for every action, there's an equal but opposite reaction. So all you do is you create a space for air to hit. And when that air hits, the aircraft starts changing direction. If you want it to do this, then what you need to do is your air needs to hit here and it needs to hit here, and then your aircraft will start doing, this kind of movement. So that's how aircraft turns. But watch that video. He goes into detail about that.
Is there anyone else with a question?
Okay. So I'm assuming there are no more questions, yeah?
Yep, sir, no questions.
Okay, that's nice. So before I close and I give over, there's one other slide that I wanted you guys to look at, to bring everything back to the Sabbath again. Remember I said engineering. I'm not sure what they were referring to here, but when you read Second Chronicles chapter 26 verse 15, it says, "And he made in Jerusalem engines invented by cunning men to be on the towers and upon the bulwarks, to shoot arrows and great stones withal. And his name spread far abroad, for he was marvelously helped till he was strong. I'm reading this because there's so many things that we can use engineering for, and part of them it is for protection purposes. If you look at during this time, they were already talking about engines. I don't know what this thing looked like, but they were calling it an engine back in the days, and there was engineering there. So part of the purpose it is for protection. One of the verses I showed there was that also God has given us all this knowledge in order for us to help other people as well, not only to spread the gospel, but to also help other people by helping them with food production, by giving them electricity, by communication. There are people who, like us now, who are talking. Other people can't do that. They can't talk to their friends and their families, and that is why God has given us engineering. We have the gospel spreading to places that we've never thought it would because of these channels. And then the last thing that I wanted to say was that engineering itself originates from God. If you read Exodus 31 verse 3, it says, "And I have filled him with the Spirit of God, in wisdom and in understanding and in knowledge and in all manner of workmanship." So no matter how brilliant people think they are, what we are learning here is that God is the one who gave them that knowledge. So your Albert Einsteins and all their theories, that knowledge came from God. And he can also give it to you guys as well. I know most people are scared of engineering because of the maths and the science. Others are scared of engineering because they don't understand it. So others are scared of engineering because they don't want to be dirty. As I said, if you are an engineer, you are more likely to work in an office than in a workshop. And also, if you are an engineer, your dad worked. Sorry, and if you're an engineer, you are more likely as well to sorry, I just saw someone saying something. You are more likely to be far from the action, if I may call it like that. That is why I was saying that it is important for parents to look at what is it that you like doing. If you don't like maths and science, if you don't like word sounds, things like that, maybe engineering is not for you. But if you like to work with your hands, you like to build stuff, then maybe you need to consider being a technician. So you need to consider going the route of either a college or University of Technology and specializing in the use of your hands rather than sitting behind the desk. And then these are just fun pictures. This is a bridge. If you had no engineers, this is probably what a bridge would look like. I'm sure some of you guys have seen these pictures. This is a telecommunications. This is a calculator. If we didn't have a calculator, this is what probably people would be doing when they make these calculations. And this is a laptop, you can see. And then this is an iPad. These are cars. And then these kids are watching TVs. But that's the end of my presentation. Thank you.
That was an amazing speech. Thank you so much.
Thank you.
You want to? Yes.